Now 12:01 p.m. Central Time, and I am your host, Dr. Matthew Richardson, and welcome to another stream of CosmoQuest Astro Office Hours. Um, the idea was to set up a problem for today, but I didn't get the chance to get around to doing it. But here is the plan, though. If you guys can generate a problem for us to discuss, then we'll go ahead and do that problem, depending on how difficult the problem is. Otherwise, I'm just going to be doing work. But let me go ahead and first verify that I'm streaming, and also open up a browser so I can see your chat. So just give me 1 second. Let's see. All right, Twitch TV. Good, good. And what do we got? Okay, I need to change that. So it says beginner Python 3 coding. I might have to change it later. All right, that did not load the way I wanted it to. There we go. Let me go ahead and pop out the chat. So I'm just going to quickly say hi to everyone in the chat room. See who's all here. Hello, Electrical Skateboard. Hello, Jetlander8. Hello, Michael T. Mayer. Hello, Peter Q. 1978. And hello, Uncle Bill Druin. And I'm pretty sure that I'm missing some people because it never shows everyone. I know that I just saw that Peter and Guido will be here, so yes. Hello, everyone. Well, that's funny. So it's only in your kitchen where the Wi-Fi is like working well. That's interesting. But yeah, guys, if you have any like problem, any sort of problem that you guys can think of that we can work through, we can definitely do it. Yeah, booster would probably be useful. But yeah, let me give you guys an update on my analysis. So I was able to get everything working properly. My algorithm has the ability to properly match overlapping images. And I've been able to, of course, produce a few science results from my algorithm so far. But today I'm trying to work on the main result. Well, I can't say it's the main result, but just a particular plot that I'm trying to generate for the analysis. It will basically show the size frequency distribution for craters for an overlapping region that's been imaged at 2 different incidence angles. All right. I really want to generate a problem for today, which is the reason why I'm opening up. Well, basically, I'm accepting suggestions right now. We'll just make a problem up on the spot and just work it. Making a few modifications to make sure that everything can be seen properly. Let's see, yeah, this needs to be bigger. All right. And this is somewhere, yeah. Let's see. So I'm going to change directories for this. Oops. There we go. Let's go to the source directory here. Go to the bin directory here. LS. Oh, I actually have some of the plots that I've made so far. So to show you that the algorithm is actually working, I'll actually just show you a few of these plots. Or the main plot that kind of supports the idea that the algorithm is working properly. But again, guys, if you know a problem, a physics problem or astronomy problem that you would like to work through, just go ahead and put it into the chat box, and I'll look it over and see if we can work through the problem. Let's see. Let's minimize this for a second. And which plot do I want to show? All right. Let's switch the scene. Let's remove this. Sorry, guys. Let's remove this. Let's go ahead and open up the plot. For now, I'm just going to switch it back to scene 1. I'm going to open up the plot and get things together. All right. So, where are you located? Planetary Science Institute, CosmoQuest, Crater Projects. That's where you're at. Incidence angle analysis in the bin. There you go. Overplot.png is the one I want. All right. So let's go ahead and load this up. No black space. We have to get rid of it. Let's get rid of the black space. All right. Let's see. Here's somewhere. Here you go. And I want to expand that. Let's move me. Oops, wrong window. There. And I'm going to move myself somewhere else. There we go. All right. So what I am showing here is a result of the algorithm showing that two sliced images, M1174678833R, disregard the other numbers for right now, is being paired with another sliced image that comes from M1622841113R. And so I could basically, of course, use these image IDs to be able to locate. Use these image IDs to be able to find the images online. And to do so, let's go back to scene 1. And I'm going to dedicate this particular tab for this terminal window. I'm going to go ahead and make it my MySQL. Root. I'll make this my main window, or my main tab for our database. All right. I'm going to first, of course, need, let me make sure I'm not missing any of the comments here. Well, any question or any problem is a good question or problem. All questions and problems are going to be accepted. Let's see. So I wanted to be able to, of course, show that that plot is accurate. And so my idea now is, of course, to show you the actual images. I've given you the answer, but I'm gonna still request for you guys to look at the images and see if you can determine where the overlap exists in the images. So I need to grab those image IDs. All right, let's do this. So we need to select star from images where name equals our image IDs. One image ID is M117678. Oops, missed a number there. 1174. 33RE_2_3. And so that now allows me to access the link for that image. You know what? This is going to be a lot easier actually. I don't need to do all this because I'm pretty sure I have the images somewhere on my hard drive somewhere. So let's do this instead. Let's go back to this scene. Let's go ahead and create 2 more windows. All right, so I found the images. And I'm just going to load them up in OBS. So here we go. There we go. So image, window capture, image 1. Let's try to make this all right, kind of changing the the aspect ratio, but it's okay. And the next one, image 2. So I'm going to put them here, side by side. Hopefully you can see all the features within the images. If not, just let me know and I'll see what I can do. All right. And so what portions, and of course the answer's in the background, but can you guys see the overlap with these 2 images? Note for the answer, the image on the left represents the yellow box in the plot, and the image on the right represents the blue box in the plot. And the green region within the plot was the overlap region. Oh, Peter says he can see it. Perfect. All right. Are you saying you can generate a problem for us, or are you saying you can see the overlap? Because either would be great. Move the right image down and zoom in. So right image, move it down. And you said zoom in, so give me 1 second and I'll do that. Let's see what you got there. Should I zoom in a little bit more? All right. But yeah, you got it. You definitely got it. So the lower right hand corner of the image on the left. So I'll zoom in there. This region right here. Let's make sure it just there we go. So the lower right hand region of the left plot is the same as the upper left hand region of the right plot, or the right image. Excuse me. And so yeah, my algorithm can now find the overlap regions correctly. And so right now, I was just trying to make sure that one of the plots I'm making is coming out right. All right. Hey, Keeper of Maps. Yeah, that's it, Peter. That's it. Oh, okay. That's a hand wave. All right. I was wondering what that was. All right. I'm gonna switch scenes. And again, to anyone who just recently joined, I mean, right now I'm just gonna be doing some work. But if you could generate a problem for us to work on, if you could generate a problem for us to work on, by all means, just post it in the chat, and I'll more than likely get rid of all of this and then set up something else. A 7-inch screen would make it quite difficult to see it. Um, but the plot itself in the background, which I'll just quickly bring up, the plot shows what the overlap should be. All right. So I need to open up a few more source code files. Yes. Any problem that you can think of, just go ahead and post it in the chat, and we'll attempt to work it. Hopefully, it's not too hard. But even if it is, I mean, that's okay. Let's see. I need to go back to my terminal here. Right. So that's some plot. And yes, this is where I left off at. All right. I think this is where I left off at. Yeah, this looks right. All right, so I'm basically going to be modifying um, this function that's in the plot class called incidence angle statistics. And the parameters I'm passing to it are, reading it from left to right, the incidence angle of a sliced image, of sliced image 1, or no, not sliced image, but this is the incidence angle of image 1, where image 1 corresponds to a full LRO image. The incidence angle of image 2 is the second parameter, again coming associated with a full LRO image. The third parameter is the scaling of the sliced images that I want to be able to do the comparison with. So what I mean by that is, for each full LRO image, we slice them up into smaller images. And each of the smaller images have a scale level associated with them, where those numbers can be scale level 0, scale level 1, or scale level 2. And that's basically just indicating how many pixels are within the image. At scale level 0, from a full LRO image, we've basically taken a 450 pixel by 450 pixel slice. And then going to scale levels 1 and 2, I think it's 1350 by 1350 for 1, and a little bit above 4,000 square pixels for level 3, scale level 3. My fourth parameter is basically just a vector of overlap of images that have been paired together. And the very last parameter, the fifth parameter, which is entitled marks here, are basically all of our user markings for craters within images. And the idea here is to be able to use this information to be able to produce size frequency distribution plots for each of the incidence angle values that I'm passing to this function. All right. Work out what the question is. Oh, this is different. I like this. Work out what the question is if the answer is 42. Oh man. I'm not going to lie to you. There's an infinite number of questions that can give that answer. But let's see. What would be the significance of 42? I wonder if it's associated with like recent events. Oh God, what is 54 in base 13? That's a question for you. Um, huh. I want to do that problem. What is 54 in base 13? I've never even thought in terms of base 13. Oh man. I take it that you know the answer to this. And if not, This is going to be a fun problem to work. I have not. I have not read it. I see that Peter just posted it in Slack. Yeah, I haven't. Okay, I'm gonna make it a priority. Probably sometime over the weekend. How big is this book? Let's see. Hitchhiker's Guide to the Galaxy. Okay. I now see the reason why 42 is important. Apparently, it's the ultimate answer to everything. I've heard of the book before. I've just never read it. Before. I've never read it. But after reading the plot summary, it does sound interesting. Wow. I've never really actually read much sci-fi. I mean, I love to see sci-fi movies. I haven't read much sci-fi. Will do. Oh, I see. No one understood the question. Sorry for being so quiet here. I'm actually now reading more about this about the novel itself. Yeah, I think I actually might start off with that because I do better with like listening to someone talk about a topic versus me reading it. Whenever I'm reading something, I can be very easily distracted versus if I'm like listening to someone say something. Right. So you want me to be able to determine exactly what is, I think it was what is 54 and base 13? Hmm. All right. Give me a second. I have a pencil here and some paper. I'll use this. Base 13. All right. Hmm. So we'll have numbers 1 through. I'm not gonna lie, I'm having difficulty even like determining how do I start this. Um, yeah, I do need another camera. All right. So if I'm working with base 2, there would be 2 digits. So it'd be 2 digits. There's 0 and 1s, of course. And so the first one would be, of course, 0 or 1. We would get 0 or 1. The next one. All right. So if I'm not mistaken, in my first place, I can have numbers 1 through 8 or 0 through 8. If I'm thinking about this correctly. And you said 54. So am I even like on the right track of how I should be thinking about this? Yeah, it's 54. That's what we're trying to figure it out. Figure out 54 in base 13. 1, 1, and base 2 is going to be right. So we use I think we use 13 to the n. As you already stated, you said how many multiples of the base plus the remainder. So of course, that's weird though, because 13 times 1 is 13. 13 times 2 is going to be 26. Is that how it works? Zero, 1, 3, 4, 5, 6. Yeah, you're right. So it's not 13 to the n. It'll be 13. It'll be n times 13 plus the. Gotcha. So I was thinking 13 to the n. So it's n times 13 plus the remainder. And so 54 divided by 13. God, I haven't thought about stuff like this in such a long time. And so 3, 39, 4. So if I'm not mistaken, 3, no, 4. 4, 2, 1, 52. Okay, so Peter, you were giving me the answer. And that's the reason why Keeper of Maths shushed you. That was a good one. And it was a good refresher on being able to do things in bases, in different bases. I haven't had to think about stuff like that in such a long time. Huh. Well, do you guys have any more questions? That was actually a pretty fun one. And while you guys are doing that, I'm going to still be trying to do work as well. So go back to Aquamax, my Emacs text editor. Let's get boundaries. So right now, guys, I'm just basically just checking through my algorithm just to make sure things look right so far. Marks associated with image 1. Right. Hey, Adam. Disengaging lurk mode. Tried for what? Hey, Adam. Everyone here is schooling me on how to think in terms of base 13. Can we use apple, pear, or pine cone for the decimal equivalents of 11, 12, 13? Okay. Um, Hmm. Apple, pear, or pine cone. See, now I'm wondering: are you just playing with me, or are you thinking about some other? Let's see. Hmm. Um. Okay, you must be thinking about some other base, of course. Um. And so, what base uses letters? Am I on the right track here? Okay, Okay, gotcha. Hexadecimal. Oh man, I'm trying to even remember. This is actually really fun. I'm trying to even remember when was the last time I actually thought outside of base 10. And I think the only time that I've ever had to think outside of base 10 was like I took a computing course when I was in undergrad, and the teacher was talking about other thinking in terms of other bases. Three apples. But wait a second. All right. So let's go back to what you just said, right? So let me pull this back up. And yeah, that's what I was just thinking actually. So hexadecimal uses through F, but in your situation, I mean, like for example, apple. There's that's through P, that's a P though. So 0 through 9, then to letter P. What is that? 26 would go to Z. So A B C D E F G H I J K L M N O P. So 0 9 that goes to 20. Guys, I'm actually really enjoying this conversation. All right, so, but to get back to what you just said, though, you say, can we use apple, pear, or pine cone for the decimal equivalents of 11, 12, and 13? And my question is, how will we be able to do that, right? Because as you already mentioned, base 16 only goes to F, so it wouldn't even include P's or L's. This would have to be a different base. Now I see. Okay. So basically you're encoding like the numbers 10, 11, and 12 into those symbols, an apple, a pear, and a pineapple. And that would be base 14, right? You guys are teaching me some things all over again. I quite literally have not seen this stuff in like ages. All right, I'm with you. All right, let's do another one then. You could get some wild numbers that was 5, 4 apples, pear, 6. But yeah, to understand the number, you'd have to know what base you're working in. But yeah, guys, you guys just really like made me think way back to some stuff. I haven't like had to think about using outside of base 10. That's a great question. I think that he streams on Sundays or will be streaming this Sunday. Let me find out actually, and I can answer that for you. So Adam, I just asked Joe when he'll be streaming again, and hopefully he'll be able to respond to that soon, or even join the stream and answer it himself. Uncle Bill joined. That makes sense. For everyone who's just recently joined, you guys can see that today is kind of just a laid back stream. And the current conversation is talking about different bases. Yes, that would be me. All right, so I messaged Joe, but I don't think he's available right now. So I'll just ask that that he post the information somewhere within the weekly Space Hangout Cruise Slack. Are you talking about Joe, Peter? What does six times 9 make? 54? Or do you mean something else? Yeah, I think he's now probably streaming on Sundays. Yes, I definitely will. So here's my question actually with base 13, right? How would we represent? So I know with hexadecimal, we represent numbers beyond 9 using letters. In base 13, would it be the same, or do we just, or is it optional? Can we use any symbol that we want for that base, or is it defined? And so yeah, the answer would be 42 again, right? Because 6 by 9 or 6 times 9 in base 10 is 54. But then the conversion to base 13 would be 42. Okay. Okay. So as far as courses are concerned, right? Like formal education on like how to understand different bases. What sort of courses would this show up in? Because I'm thinking back to all of my physics courses and astronomy courses, and like we never talk about different bases. However, I do remember vaguely talking about it in a computer programming course I took in undergrad. I remember the topic being brought up then. Really? That's interesting because I do not remember talking about anything outside of base 10 in elementary school. I can definitely see how that works actually. Yeah, guys, it's now 1 o'clock p.m. and I'm definitely gonna take some time to go ahead and find a copy of The Hitchhiker's Guide to the Galaxy. So everyone, thank you for stopping by. I definitely had fun talking about how to understand numbers in different bases. Next time I'll be ready for a question like that. Alright guys, I'll see you guys next week. I should be back on Wednesday, 12 o'clock p.m. Central Time. So alright guys, bye. And thanks again. I know I just said bye, but I am definitely going to see if there is any talk of using different bases in astronomy. Yeah, guys, I had a lot of fun too. All right, I'm logging off now. All right, bye, guys.